Hello.
Hey, Maria.
How are you today?
Oh, good. How are you?
Pretty well. Is it pretty late in the day over there?
It's 5. It's not that bad.
Okay. Could be worse.
Yesterday, I supposed to have a meeting with a collaborator in California, and it was like 1 a.m., so it was impossible.
Okay, well, we're gonna wait a couple more minutes for people to sign on.
Okay.
And then we can get started.
Are you recording?
Yes.
Okay, that's good. I was out of the office last week, and then this week the students are disappeared, so I don't know where they are, but then I can gather them last week or in a few days, and we can watch it together later.
Yeah. I think one of your students also volunteered to build an app as a first example.
Oh, cool. Do you know who it is?
Yeah, it was in the training channel.
Okay, let me see.
I have to scroll up. So.
Oh, is it Giulio? I think he's not.
Yeah,
He's
I
not
think it was him.
He's from Italy.
Okay. And then I think we can chat with Rang to see what else is on her wish list so that people can try out making some apps.
Okay.
So I guess let's go ahead and get started. And if anyone signs on later, they can catch up. And since there's not too many of us today, feel free to jump in with any questions. I'm happy to answer any questions that come up. So I'm going to go ahead and share my screen and talk a little bit about what is an app on DNA Nexus, how you go about developing one, all of that fun stuff. So before you can get started developing apps, you do need to install the command line client for DNA Nexus. So I have it installed already, but if you want to go ahead and install it on your computer, you can go ahead and go to wiki.dnanexus.com. And the SDK command line client is available on the sidebar over here. So you can follow the installation instructions. Basically, for Mac OS, you would download the Starball, and then after you untar it, you would source the environment file wherever you downloaded that. So it's called DX-Toolkit, and you would source the environment file. This will configure your environment so that you can use the command line client. So now if I type in DX, it'll show that the command line client is installed. And that's what we'll be using today for most of our app build process. Going back to the wiki, there's also this developer portal over here in the top bar that walks you through pretty much the same tutorial I'm going to do today, which is how to build an app easily on the DNA Nexus platform and sort of what's required. And so if we, there's no overview here of what is an app, but I'll give you a very quick overview. Basically, an app has 3 different components. The first component is a JSON file, which is a definition of the inputs and outputs of an app. So it's just your app specification. The second component is a script that you use to run the app. So it's usually a Bash or Python script that has all of the instructions of which commands, which scripts, which executables need to be executed inside of your app. And then the third component is the actual binaries or dependencies that go into the app. So if we take a look at a really simple VGP app, this is in the VGP assembly GitHub page. And I can take a look at this concatenate 2 files app. So you'll see that it has a README that just is some optional documentation describing what the app does. It has this dxapp.json file, which is a specification of all of the inputs in the app, all of the outputs in the app, and then sort of what kind of system the app should be running on and what the script is that the app should be running. And then finally, it has this source directory, which has the script that runs the app. All of our apps run on Ubuntu machines, so it has some standard Ubuntu commands like cat and ls and stuff like that, so it doesn't require any binaries for this particular app. But you can see that this app follows a pretty standard structure for us. So the first thing it does is it downloads the input files into the worker that is running the app. Then it executes some kind of command or some kind of script. It can be any kind of arbitrary script or binary. And then it uploads the outputs and then links the outputs back to the project. So that's the basic structure that we'll be following for almost all of our apps. Any questions so far on how apps are structured? Okay. So once we have the command line client installed, in the command line client, we can log in to the DNA Nexus platform. So I'm just going to log on here with my VGP account. And then once I'm logged in, we have some useful utilities in the command line client specifically for app building. So I can select a new project to work in using the command line client. So I'm just going to do a dx new project to create a new project. And you can, if you're not familiar with the command line client, you can do dx-help to see all of, dx help all, sorry, to see all of the commands that are available. But basically anything you can do on the web UI, you can also do through the command line client. So once I'm logged into the platform and I've selected a project, we have this utility called dxAppWizard, which will help generate a template for my first app that I'm going to build. So it's dx-app-wizard, and then it will ask me several prompts about the app that I'm building so that it can generate a template for me. So if I want to do a very simple example app like the concatenation app that I showed you, I can give it an app name and then just give it a human readable title of describing what the app will do. and a summary. And then a version. So most of the apps that we use are actually built and published so that the entire organization can use them from the run analysis screen. So what we'll be building today is actually an applet, which is a development version that just lives in a single project. But you could potentially build an applet into an app that is shared with everyone. So for now, I'll leave the version as development version 0.0.1. And now I can specify the inputs that I expect the app to have. So my first input is just going to be file 1, since I'll be concatenating 2 files. And I can specify a human readable name for it, as well as the input type. So I can double click tab twice to show the choices. So we have all kinds of possible input types. You can have an array of files, you can have an array of integers, you can have a single file, you can have a string or an integer as an input. So it just specifies what kind of constraints you want to put on your input type. And that also corresponds to what it will look like when you build the app, in terms of what it will look like on the web UI to specify the inputs. So my inputs are both going to be single files. And I can specify that this is not an optional parameter, but I could also have optional inputs. And then I'll do the same for the second input. Once I'm done entering my inputs, I can just click enter to finish. And I can start doing the same thing with my output types. So for this app, I'll have a single output, which is my concatenated file. Which is also of type file. And that will be the only output that I will specify. Another thing that the wizard tells you to specify is the timeout policy. So as you may know, if the app reaches something like an out of memory error or something that is not detected as an error, it could keep running forever without any kind of checks or balances on it in terms of how long it runs. And so it's very useful to specify a timeout policy for an app, which is the maximum amount of time you would expect an app to run if it's actually running successfully. That way you can avoid costly billing if your app has a silent failure or gets stuck and runs forever. So for this app, I'm going to specify pretty short timeout policy, since the operation that it's doing is pretty simple. So we're going to do a 6-hour timeout policy, but it really requires knowing how long you expect your app to run to specify a smart timeout policy there. And then I can also specify what kind of programming language I want to write my app in. So this is just the wrapper script for executing commands on the app. For simplicity's sake, I'm going to use Bash today, but you can also make somewhat more complicated apps using the Python bindings. But it doesn't mean that you're restricted to only using Bash or Python inside of your app. It just means that this is how you're going to write your wrapper script around your binaries and commands that you're executing. Then I can set additional permissions for the app, which we won't need today, but you can have apps that access the internet, you can have apps that access the parent project, or access certain ports. There's a lot of customization you can do there. And finally, I'm going to add a default instance type for my app. As you may know, users can also change the instance type when they run the app, but in this case, we'll just specify the default developer recommended instance type. So once I've filled in all the questions in the tutorial, it will generate this app template for me. And you can see the files that were created. So it created this dummy README file they can fill in to add documentation to my app. It's generated a dxapp.json object with all of my input and output specification that I specify. And then it generated the source script, which is a template for how my app will execute commands. It also generated this resources directory, which is a place where you can specify any binaries or any scripts that you want to add to the app. This is only one way to add dependencies to the app, but it's the most straightforward. And basically anything you put in here will get dropped into the root folder of the worker you're running the app on. And we'll go into that a little bit more later. So if I go ahead and open the source bash script that, I'll just open it in Sublime here. So if I go ahead and open the source script that was generated for me, I'm just gonna navigate to that directory and go ahead and open it. We can take a look at the template that was generated. So here's our concatenation example. And here's the bash script that we generated using the DXAppWizard. And you can see that it already does the basic operations for us in that it downloads our input files, and then it specifies our output file and links it back to the project. But over here, we can fill in any custom executions or binaries or scripts or commands that we want to run inside of this app. So the first thing I'm going to do is change my local file names. So when it does DX download, it takes this remote file and then downloads it to this local location. So I want to make sure it downloads it to the actual file name. And for that, I have a helper variable. So I can do file1_name. And that will be the same name as the file has on the platform. And I can do the same with file2. And then I will add a command here, which will concatenate my two files together. So I can do cat file1 name and file2 name into some output file. And I'll assume these are text files for now, but you could obviously get a lot more complicated with the logic. And then I will take my output file and upload it into this concatenated file variable, and then add the output, meaning link the output back to the project using this file ID that I get from uploading the file. So if I go ahead and save this, I can go back to the terminal and I can now DX build this concat example applet. And if I don't have any spelling errors or typos or anything like that, it should be able to be built successfully into the project that I created. And so it gives me this applet ID. And so now if I go back to my project, I can log onto the platform using the web UI and go over to my app development project, and you will see this applet now inside of my project. And then you should be able to see the file inputs that I specified and the file outputs that I specified. I haven't specified any parameters other than the default instance type. And if I had filled in any of the README information, it would show up here. So another useful thing we can do with this app is, for example, I know that all of my input files will be FASTQ files. And so that's something I can go back and specify in the dxapp.json definition. So if I go back to my text editor, I can open the dxapp.json in my app directory. And it's already filled in with everything I specified in the dxapp wizard. So I have my file1 input and my file2 input. But I can start adding things like the file pattern. So here I can specify that my file will be a FASTQ file or a .fq file. And I can do the same for my second input and specify the same for my output. And then I can also add some help documentation saying this is my first file to concatenate. This is my second file to concatenate. And then my help documentation, which is this is my concatenated output. And then if I go ahead and save that, I can change my output file to be a FASTQ file in my script as well. And then if I go back to my command line client, I can now build the app again, this time specifying -f, which will overwrite the existing app that I already have. So it deleted the previous app that we built and rebuilt this new definition as a new applet. And if I go back to my project again and take a look at the changes that we specified, you will now see that this now has a file pattern that it searches for. So it has this FASTQ filter, as well as this FASTQ expected. And then if I hover over the inputs, you'll see the help documentation that I filled in. So those are the basics of a very straightforward app. There are more complicated things we can do with apps. So if I open up this tutorial page, we have a tutorial page that we maintain called DNA Nexus Example Applets, and I'll paste this link on Slack so you can all take a look. But the basic idea is that it has a bunch of different apps that are already implemented as tutorials so that you can see some different app patterns for making apps. So for example, there's this very basic samtools count app. And you can see it has the dxapp.json file, which has the mappings BAM as an input. And then it also contains the samtools binary inside of it. And so here you can see that it's running the samtools view command and then uploading the output. And if you click here, you can actually see the source code on GitHub that was used to generate this tutorial. And we can take a look at how the samtools binary was added to the app. So in this case, it was added using this exec depends command. This is one way to add binaries to your app that are available through some standard libraries like pip or apt-get. So the default is apt-get, so it will download samtools using apt-get install samtools. But you can also specify something like pip install some library that is a dependency for your script or something like that. But if we wanted the most recent version of samtools, which isn't available on apt, what we could do is going back to our command line client, we can go to that resources directory that we created in our example. And under resources, I'm going to create a user bin directory. So remember, resources is the root of your worker. And so anything you put in your user bin directory, you will it will show up in the user bin directory in your worker. And so if I copy the samtools binary from a downloaded location, for example, if I wanted to download the latest samtools into this user bin directory, it will instantly show up in the user bin of my app, and I can use it as a dependency. So I might have samtools in my local user bin. I do not. But if I did, I could copy it from my local user bin into this app directory, as long as it was compatible with Ubuntu, and then it will show up as a dependency in my app. Any questions so far?
Yeah, 2 quick questions. Can you hear me?
Yes. Mm-hmm.
First one, if I chose Python instead of Bash for
Yep.
the app language, is it 2 or 3?
It is 2.
And are there any DNA Nexus related libraries that are automatically available in a Python script?
Yeah, so we have the DXPy, which is our Python client, and that gives you Python bindings to all of the HTTP API operations.
I mean, if I'm in Python, do I just say import DX client?
Yeah, it's import DXPy.
DXPy, okay.
So I can show you an example using Python in our example apps tutorials. So if I go back to github.io and go back to our tutorials, there's some very simple example Python applets. So let's take a look at this one. And so in your script, I'll just go to the source code here. It has, again, the source directory. Here we have a Python script instead of a Bash script. And then you could import this DXPy client. And that lets you do basic things like download a file onto your worker, and describe a file on the platform, stuff like that. And so you can see, I think it should be, so it uses just a download all inputs script over here, which just downloads all of your inputs all at once using DXPy, but you could also download inputs individually. And we do have a pretty robust Python documentation for that library. Any more questions?
Yeah, Maria.
Yep.
Could we get the hardware specs for the workers if you wanted to compile our own binaries?
Yeah, so all of the workers run either Ubuntu 14.04 or 16.04, which you can specify in your dxapp.json. And then the hardware specs will vary by instance type.
Okay. Can we get a list of those hardware specs somewhere?
Yeah. So I believe in our wiki, we do have a list of instance types.
Okay.
But I will dig that up for you and send it over on Slack.
Okay.
And then I wanted to talk just a little bit about more advanced type of app, which uses subjobs. So in addition to running your binaries on a single worker, you can specify for your worker to launch a whole bunch of other child workers that will perform the analysis on a region, for example. So you can split your inputs by chromosomes, or you can split your inputs by regions in a genome. And so if we go back to this example apps, I believe this has, yes. So we have what's called entry points. In Bash, it would be just another function that you would call from your main function. And in Python, there's a special decorator to wrap around your functions to make them into entry points. But if you do want to develop some parallelized apps, I'm happy to help. It will be a bit more of a hands-on process since it does get a little complicated. But the main idea is that you would specify, if I go to the source code here, you would specify your main function, which doesn't do any processing. It usually just splits up your inputs into chromosomes, for example. And then in your main function, you would have this dxutil new job command, which will launch a new job with new inputs as a subjob of this main function. And here you would specify your subjob function. So this count function is actually another function in the same source file. And this function does some analysis on just a single chromosome or just a single region, and then returns the outputs. And then finally, you would have a third function, which just does some kind of gather step. And so, oops. And so in this main function, for each chromosome, it runs this dxutil new job subfunction to launch a new job for every function that it ran. And then at the very last step, it runs this new function to gather up all of the outputs. And then it adds the final output, which is the output of the gather step. But this is just to give you a very, very brief overview of how the subjob chunking works as just a very basic design pattern. This is a more complicated example, so I won't go too deep into it. And I would encourage everyone to just focus on the very simple example first, and then explore the more advanced app tutorials as a next step. Any more questions? And so finally, I wanted to walk a little bit through the VGP GitHub page. So we do have the VGP assembly GitHub repository. under DX applets, you can find the source code for all of the applets that were implemented for the VGP. So it has all of the scaffolding steps, some minimap alignment, some SCAF10X, salsa, stuff like that. And so you can see how those apps were implemented and potentially make changes to them in the future if you wanted to. So for example, the Salsa app has what's called an asset, which is another way to specify dependencies in your app. It is a separate build step. And so the idea is if you have libraries that take a while to install, or that you want to preserve a certain library version, you can create this fixed dependency bundle that you would then associate with your app. And so if I wanted to make changes to the Salsa app, for example, I could update the version here of which Salsa I'm using. All I would have to do is update this tag to the latest version. And then if I go back to the command line client, I can navigate over to that Salsa app. And then here you will see this asset folder. So in order to build this dependency bundle, I would do dx build _ asset and point it to that asset folder. And what that will do is it will run a job on the platform that will install all of those dependencies using both the specification that I have and any make file that I want to include in there, anything like that. And then take a snapshot of the worker with all of those dependencies installed. And then I can use that snapshot to attach it to a new worker that's running the job. And all of those dependencies will be available. So if I do dx build assets, it will upload all of my asset files from my local machine up to the platform. So that's the dx asset definition, any make files that they want to include in there. Then it will launch a job to build that asset. And that job will run everything I specified. And then when the job completes, it will give me a record ID, which is pointing to that snapshot that's created. And then in my dxapp.json file, if I navigate over here to my dxapp definition, I can update that record ID under this asset depends definition. And that's another way to attach dependencies to an app that I'm developing. Any questions about assets and dependencies in general? So if I go back to the command line here, I can see that this finished successfully with my new Salsa version. And then in a moment, it should give me a new record ID that I could update in my app if I wanted to. There we go. So this is the record ID that I would then add into my dxapp.json. Another thing I can do is if I have an app that I've developed and I want to make it available to everyone in the VGP organization so that they can run it, if I go back to my concat example, when I do dx build on my example applet, I can add this --app flag. And instead of building it into just an applet in my parent folder, it will build it into an app that I can then version and publish to my entire organization. I think this will complain that I didn't specify a couple of required fields for my app, but basically it creates a permanent version of the app that is pretty much immutable on the platform and has a global definition. And so if I publish this app using this dxpublish command, and then I can add users to this app, like I could add the entire VGP organization as a user of this app. Anyone who belongs to this organization would be able to see this app and run it when they use the platform. And so most of the apps that we build for the VGP are built and published in this way and versioned. And what's really useful about that is we can also write down some of the workflow definitions that link those apps together. Any questions about publishing and versioning apps? So in the last few minutes, I did want to talk a little bit about workflows. So in the VGP assembly GitHub page, there is also, in addition to this DX applet source code, there's this DX workflows source code. And this is where we keep all of the workflow definitions for any of the workflows that are built into the VGP tools project. And so any changes to those workflows first happen on GitHub and then get built into that project. And if I click one of the workflow definitions, for example, Salsa, it consists of a JSON object, which can be built directly into a workflow. You'll notice that it has stages. Each stage is an app on the platform. So you can see this executable field, which points to a specific app name and a specific app version. And it also contains links between the input of one app to the output of another. So for example, the second step, which is the ARIMA mapping step, points to this app with this specific version, and it links the input for that app as this output field from the previous PWA FASTA index app. And so this allows us to also have, in addition to having versioned apps on the platform, we can have versioned workflows on the platform. And so we can always rebuild a workflow, even if there are any changes that happen to it or anything like that. We can rebuild it from the source code. Any questions about workflows or anything we covered today?
Hi, Maria.
Yeah.
Julio, I'm sorry, I had a problem, so I was a bit late, and so I missed the first part of your talk or presentation. And since also I have to generate one of these apps, I have, maybe you already covered that, but just do you have, so is there also, I mean, first of all, the recordings of this particular session are available afterwards?
Yes.
Or no? Okay, so I can. And then is there like a tutorial or some available resources where you have all, let's say, I mean, everything is explained?
Yes, so there's 3 sources of tutorials. Like I mentioned at the beginning of the presentation, we do have a template that we can generate using the command line client. And so I think that's the best first step. And that will walk you through just how to specify inputs and outputs and stuff like that. And then in our developer portal, so if you go to wiki.dnanexus.com, we have this introduction to writing apps. You can also access the developer portal from the platform by just going to any page on the platform, and you'll find this help tab in the top. So you can go to the developer portal, as well as just our general wiki page. And that will take you right here.
Okay.
And then the third source is we have this github.io site that has some example apps and applets with different design patterns if you wanted to take a look at those. And I'll paste this link into the VGP Slack channel. And then finally, all of the VGP specific apps are in the VGP Assembly GitHub page under DX Applets. And so you can look at how the existing apps for the VGP were implemented and copy the source code of one as a starting point for developing your own.
Right. Okay. And do you have any specific suggestion for the ASM Stats app, or?
Yeah, so I didn't take a look at it too closely, but it looked like it uses some Java dependencies. And so what we usually do with Java apps is like we did with Salsa, there's this exec depends field, which allows you to install any dependencies, for example, from apt or pip, any kind of standard library dependencies.
I see.
And so the first thing I would do is use exec depends to specify GRE dependencies, like GRE headless 6 or something like that, which allows you to run Java programs. And then you can specify your Java binaries in the app resources directory. So you can create a directory under there that will put them, for example, under user bin to upload them into your app.
Okay.
And then you should be able to run the script in a pretty straightforward way once you've downloaded all of your inputs.
Okay. How much do you expect the overall process should take? I mean, the developing the app.
I think it shouldn't take very long. Maybe half a day to a day of development time.
Let's see if I can make it.
Yeah, and feel free to reach out if you have any questions.
Okay, thank you. Thank you.
And then I'll sync up with Arang to see if there are any other apps that could be good examples to work on that are also in sort of the VGP wish list of apps to develop. I think Freebase was one of those apps that.
You mean the one that is where we separate these scaffolds?
Yeah. So if you go to Arang's scripts, she has a different pattern for running Freebase. Where I think she launches 100 jobs with different contigs in each job. And so that's a different design pattern than the standard Freebase app that we have on the DNA Nexus platform. And so if someone wanted to implement a VGP specific version of Freebase that uses the exact script that Arang does when she runs it locally, that could be useful as well. And yeah, go ahead.
Because I think the problem here is that I mean, Freebase is not, I mean, it cannot run in parallel by default. So the current release. So does your app on DNA Nexus has been like parallelized independently, or?
So the app on DNA Nexus runs the parallel Freebase script, which is included with the Freebase distribution.
Really? Okay.
Yeah. But that brings me to another point that I think is important to mention, is that any apps that are published on DNA Nexus and designated as open source can be downloaded locally So if I go back to the command line client and I wanted to take a look, for example, at how the Freebase app is implemented on DNA Nexus, I could run dxget on app Freebase, and that will download the Freebase app into a local output directory. I think I got logged out again, which is why I'm getting this error, but I should be able to see Freebase, and if it works successfully, I would see the source code and the dxapp.json definition for that public app on the platform. And so I could do that with any app that is public on the platform to take a look at the source code and how it was implemented, or try to implement my own version.
Okay, well,
and that's running this dxget command. Yeah.
I think I have to look a bit into that, because I mean, it's been a while ago, but I remember that Freebase was not parallelized at the time. So maybe they improved that, and I remember there were some few people that developed their own scripts for parallelization. I don't know if that's something that they recently implemented into the official release or whatever. But yeah.
Yeah, so I think in our version of the app, we just use the official release and include the script.
Okay, well, okay.
Yeah, any more questions about developing apps on the platform, and any other resources I can point you to get started? I see someone said something in the chat window, but I can't see it without exiting share screen. Can anyone read the chat window?
But I cannot really access that. So
okay, let me
maybe it was only to you. I don't see anything.
Okay, let me stop sharing for a moment.
Yeah.
Okay, it was only to me. It was just Chul saying thank you. Any other questions that I can answer on the call? Otherwise, I'm happy to answer any questions over Slack as they come up and as you're developing your own apps.
Yeah, that's great. I also think I will try some simple ones first, and then just build up the knowledge from there.
Yes.
And talk on this
Yeah, my recommendation for a simple app to get started is usually something very, very simple, like a SAMTools count app, which will just count the number of lines in a file using the SAMTools binary. That's usually a pretty good example app for people to get started.
Okay. And for testing the app, what happens if we let's say develop one and we wish to test it? Also, I mean, assuming that maybe one is cheap, one other one is more expensive, or.
So typically we test the apps in a project. We did allocate some funds, I think under Myers Lab. There's some funds available for app development and testing. Okay. And so you would run it in a project build.org and just use small inputs to make sure everything is running correctly.
I see.
Any other questions? Okay, well, thank you everyone for your time, and we'll sync up on Slack if any questions come up while you're developing your own apps.
So
thanks, Maria.
Thank you, Maria. So the recordings will be available right now, right? So
yes.
Okay, great. And sorry again for having joined late.
No worries. Take care.
You too.
Bye, guys.
Bye-bye.